Hello, welcome back. Hope you enjoyed the video there. We were looking at a question on cards there. We covered a bit of probability theory, and we were about to go into a bit more detail. But I want to give you another question. Okay, so we'll just show a slide there, and in these slides, I'm trying to show you data in different ways each time, so that you can kind of acclimatize yourself to the different types of way the questions are fired at you. So in this question, we have the following table shows the number of males and females that participate in different sports. Now, I can understand if we see the table, we just see male, female, rugby, swimming, football, tennis, a load of numbers. Okay, what do we do with them? Okay, what I would do initially is to add up the amount of males, add up the amount of females. There's a question there on is the person female? Okay, so do that straight away so that you give yourself a head start and get in the practice of doing that with the question, so that you're acclimatizing yourself to what's coming up, okay? So the question is, a person is picked at random. Find the probability that the person A is female. So remember, the probability of an event is the number of successful outcomes divided by the number of possible outcomes. So our successful outcome is the person being female. So how many females are there and how many people are there in total? Well, there are 41 females. So the probability that the person is female is 41 out of a total of 80. So I hope that you were quick with your adding. You found that there were 39 males and 41 females. So it's literally as simple as that. The probability is that. And if you want to give it in a decimal, you literally punch it in a calculator, 41 divided by 80, and it'll spit you back a decimal, as long as it's on the right mode, okay? So don't be afraid if it keeps throwing you back the fraction. Be careful, your calculator does have different modes, okay? Now, so that was reading the numbers across, the 8, the 11, the 8, and the 14, adding them up and sticking them over the total number. Now we're going to go down. Does the person play tennis? So we're looking at the tennis column and adding 10 and 14 to find 24. The probability that the person plays tennis. So what was that? 24 out of a total of 80. And we can whittle that down again to 3 over 10. So again, putting our answer in its simplest form. Then finally, that the person doesn't swim. And as I said before, you can put the English into your brackets. In a more complicated question, I would avoid this. I would say let A be, or let F be the event of the person being female, or let T be the event of the person playing tennis, and I would do it in that way. So we're finding the probability that the person does not swim. What's the rule that we do there? That's another key word, that they don't do something. What can we use? We can use the complement of an event, so we can get the probability of them swimming, that the person does swim, and do 1 minus the probability that they do swim. Okay, so how many people are swimming? There's 8, 11, there's 19 people swimming, and we simply do 1 minus that fraction, and we find the answer. We find the probability that they don't swim. Okay, so 1 minus 19 over 80 is going to equal 61, am I right? 61 over 80. Yeah. Okay? So another example of how the complement of an event can come into practice. Okay? All right.